In Spiral 1, we looked at using right triangles to solve problems. In Spiral 2, we looked at the sine law. And in Spiral 3, we looked at the cosine law. So now we're just putting it all together. We're going to be selecting a trigonometry strategy. So when you're faced with a problem where you can use trigonometry to figure it out, how do you know whether to use the primary trig ratios, sine, cosine, and tangent, or the sine law, or the cosine law? How do you know? Well, you can use a decision tree to help you decide. So when you have a problem that involves a triangle, the first thing you want to ask yourself is it a right triangle? If yes, then you know you can use Pythagorean theorem or sine, cosine, tangent. So we covered Pythagorean theorem in lesson 102 back in Spiral 1. We covered the primary trig ratios in lessons 103 and 104. So with the Pythagorean theorem, remember we label the sides A, B, and C, where C is the hypotenuse, and A squared plus B squared equals C squared. So you would use this formula to calculate the missing side. If you know two sides, you can calculate the missing one, as long as you're putting the hypotenuse in the right spot. If you're looking for use of angles and sides together, then you have to use your primary trig ratios. And the primary trigonometric ratios are sine, cosine, and tangent. So for any angle, labeled here as the Greek letter theta, we can label the triangle as having the opposite side on the directly across. The hypotenuse is where it usually is, across from the right angle. And the adjacent side is just the other side left over. So sine of the angle, sine theta, is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse, and tangent is opposite divided by adjacent. And we looked at how to solve for a missing side or a missing angle using these. So if you have a right triangle, you can use any of these strategies. Now let's go back to our question. Is it a right triangle? What if the answer is no? Well, then you have to do something else, and you have to ask yourself another question. Do you know an angle and its opposite side? So, for example, in this triangle, I know an angle and its opposite side. So if my answer is yes, then I can use the sine law. And if my answer is no, then I can use the cosine law. So depending on whether or not you know an angle and its opposite side, that tells you whether or not you use the sine law or the cosine law. The sine law we covered in lesson 201 back in Spiral 2, and the cosine law we covered in lesson 301 in Spiral 3. For both of them, you can calculate a missing angle or a missing side using the correct formula. So these are all the different strategies we have when it comes to trigonometry problems. Your job is to analyze the question to figure out which one is the best to use. And in any given problem, you might use a combination of these different strategies depending on what information you have. Let's do some examples. A 10-meter ladder leans against a wall. The top of the ladder is 9 meters above the ground. Safety standards call for the angle between the base of the ladder and the ground to be between 70 degrees and 80 degrees. Is the ladder safe to climb? I always try to draw a diagram first if I'm not given one. That way I can visualize what's going on. So I have a ladder leaning against a wall. So I'll draw that. The ladder's 10 meters long. The top of the ladder is 9 meters above the ground. Now, because it's leaning against a wall, walls are always 90 degrees to the ground. So we will put that in our diagram. We'll assume that's a 90-degree angle. Then it says safety standards call for the angle between the base of the ladder and the ground to be between 70 and 80 degrees. So where's this angle between the base of the ladder and the ground? Well, here's the base of the ladder, here's the ground, that's the angle between them. So we have to find out what this angle is. So do we have a right triangle? Yes. So we can either use Pythagorean theorem or the primary trig ratios. Well, we're not trying to find the length of the missing side, so we're not going to use Pythagorean theorem. We're going to use a trig ratio. Which one do we use? Well, this is the angle I want. This is the opposite side. This is the hypotenuse. So opposite and hypotenuse, that's sine. So I'm going to use the sine of my angle, plug in my values for the sides, and don't forget, if you're finding the angle, you have to do the inverse sign in your calculator using your shift button or second function button. So when we do that in the calculator, we get 64 degrees. So this angle is a 64-degree angle. Is the ladder safe to climb? Well, no, it is not safe to climb because it's not between 70 and 80 degrees. A cable car stops part of the way across an 86-meter wide gorge. The cable holding the car makes an angle of depression of 57 degrees at one end and an angle of depression of 40 degrees at the other end. How long is the cable that holds the car? So again, let's just start by drawing a diagram. So here I have my cable car suspended by cables partway between the two sides of the gorge that's 86 meters wide. Angle of depression is from the horizontal looking down, so it's 57 degrees at one end, 40 degrees at the other. And I want to know, how long is the cable that holds the car? Well, the cable is this and this. So I need to find this length and this length and add them together. I'm going to call this A and this B. So I'll find the length of A first, then I'll find the length of B separately, then I'll add A plus B to get the total length of the cable. Now, one thing you can keep in mind here is at the bottom of the gorge, it's 86 meters wide. It's going to be 86 meters wide at the top too. So now we have my triangle here that I can use trigonometry to solve. Okay, is this a right triangle? No, I don't think so, unless this is a right angle. So let's check. All the angles inside a triangle should add up to 180 degrees. So that makes this angle 83 degrees. So this is not a right triangle. That means I can't use sine, cosine, or tangent, those trig ratios. That means I have to either use sine law or cosine law. Okay, so the next question is, do I know an angle and its opposite side? Well, yes, I do. Here's an angle and its opposite side. I know that matching pair, so I can use the sine law. That's how I'm going to solve for this length here. So I'm going to find A. It matches up with the 40-degree angle. Those are opposites. And this side, 86 meters, matches up with the 83-degree angle. So I'll write my sine law like this. Now I use cross multiplication to solve. And when you plug it into your calculator, you get an answer of 55.7 meters. So this part of the cable is 55.7 meters. Now a lot of people make a mistake here. They say, well, this is 55.7 meters. That means this is also 55.7 meters. But that's wrong because this is not an isosceles triangle. These sides are not the same length. If these angles were the same up here, then you could say that. But since they're not, you can't say that those two sides are the same. So we're going to have to do the sine law again to find side B. So this time B matches up with sine 57, and we can use the same 86 meters matching up with sine 83 degrees. And when we do that calculation in our calculator, we get 72.7 meters. So this part of the cable is 55.7 meters. This part of the cable is 72.7 meters. So how long is the cable that holds the car? Well, I have to add those together. And that comes out to the cable is 128.4 meters long. A sewer pipe for a new subdivision has to be laid underground. A connection is made to the main service pipe at either end of the 4.8 kilometer stretch of road. One pipe, 2.5 kilometers long, makes an angle of 72 degrees at one end of the road. So here we have a diagram to represent that. Calculate the length of the second pipe that will connect the first pipe to the other end of the road. So the length of the second pipe is this side of the triangle. So is this a right triangle? No. Do we know an angle and its opposite side? No, because this is the only angle we know, and we don't know its opposite side. So that means we're going to have to use the cosine law here. So if this is side x, I'm going to use the cosine law to find the length of x. So I just set up my cosine law, do the calculation, and solve. So I can see that the second pipe is 4.7 kilometers long. Part B asks, what is the measure of the angle made by connecting the two pipes? So what angle is that? Well, here's the first pipe. Here's the second pipe. What angle is made by connecting those two pipes? Well, where do they connect? They connect right here. This is the angle we're looking for right there. So angle Z is the angle we want to find. Let's use the cosine law again. So I'll set it up. Remember, the opposite side is 4.8, so that's the one I subtract in the cosine law. You have to be watching for that. Now I just plug it in my calculator, and don't forget to do the inverse cosine at the end to get the angle. So the two pipes make an angle of 77 degrees. Now before I finish the video, I just want to point something out here. After this point, when I found out what the length of x was, I had an angle and its opposite side. I could have used sine law to solve this question too. Either way you do it, you're going to get the same answer. I just wanted to point that out there. You didn't have to use cosine law here. You could have used sine law as well, but they both work.